E, not C, and we'll go over it together. Okay. So as you can see, this is, as I mentioned actually even earlier, the arm, especially around the elbow, is a pivot point. So you know this is a torque question, right? And with all torque questions, you know that there is depends on distance, right? So let's look at force diagram, just like with all force problems and even torque problems. So there's a downward force of 10G, G as in the 9.8, right? Downward, and there's a force upwards, right, along the bicep. And the bicep, you can think of it almost as a string or rope. So the force is actually a tension, right? Muscles are very similar to strings and ropes. So they would be using tension. Right, and we know that this is the point of pivot, the elbow. And we try and always use meters. So this 35 centimeters long is 0.35 centimeters away, or 35 meters, I should say, my bad. 0.35 meters away. This force is being applied 0.02 meters away, right? And it's applying an upward force. So,
I have a
yes, please.
Is that 10 grams?
No, it's 10 times G. G as in 9. G is equal to 9.8. It's yeah. So it's normally it would be mg. We know the m is 10. G is 9.8. It's not grams. It's 9.8.
Oh, 10
sorry.
kilograms. Okay.
Yeah.
And
so G is Go ahead.
And is that dot where the 75 degrees is that the pivot point? Is that the elbow?
Yeah. This is the elbow. This is the elbow. This is the pivot point, right? Okay, so this is 0.02 meters away from the pivot point of the elbow. So you know, essentially, you want it to keep staying. So you want the F net to be 0, right? You know that you have a force coming here and a force pushing up here, right, by your bicep. You know that this force is equal to 98 newtons, right here. And then because of torque, the torque is actually, even before you even begin to think about torque, you know that it can't be D or C, because as I mentioned, going close to the point of pivot is very difficult, and you need to apply way more force in order to get the same torque as if you rather than if you were doing it far away. Since the weight is at the end of your arm, it's very far away, so it has a very high torque. In order to get the same amount of torque, but just by pulling here, you would need way higher force because the distance is way smaller. You would need a way higher force than 98. So it would actually be like over 1,000, right? So you can already eliminate C and D, and it's get down to at least 2 answer choices. So if you were to, I guess, pretend for this that this angle didn't exist and it was just a straight line, then you would have T as the tension times 0.02 is equal to 98 times 0.35, right? You do this, then you'd multiply these out, and then you'd divide these by 0.02, right? And that's how you get the tension. So when you do that, and I'm not going to do the math right now, but this is what you would do. And then once you do that, you'd get a tension, right? And the tension would be about like 2,017.50, something like that. Well, you know, you can see that this is at an angle, right? It is a 75-degree angle. So then you have to think, okay, well, which component am I looking at? Well, you're looking at this top component, this one going up, right? This would be sine because it's opposite. It's right here. So it would be opposite from the angle over the hypotenuse, right? So it would actually be sine 75, right? because it's opposite over hypotenuse, so it's sine. However, sine 75, you may not know what sine 75 is. I don't know what sine 75 is, but I know that it's very close to 1, right? Because you know that sine 90 is 1. Whereas sine of 60 is, I think, radical 3 over 2. It's very close to 1. Sine 75 is very close to 1. Essentially, you can almost consider it as there is no angle, as it is just a flat up. So you wouldn't, in order to get 3800, so the tension you would get if it was flat would be about, I think 1750, I believe, if I remember right when I calculated it. You'd need to like divide by 2. So you'd need a sine of 30 in order to get A as your answer. Sine 75 is nowhere near sine 30. It's much closer to sine 90, which is 1. So therefore, B is the only choice within that range. It's the only choice close. Okay, now I'm going to look at the answer choices. Okay, so how did I, first question, how did you get 98? So we know that this is a mass, right? In order to get a force, you would multiply M times G, right? The mass is 10, G is 9.8 meters per second squared. G is the gravity constant, 9.8. 9.8 times 10 is 98. Like Tim said, you can often round it to 10. Just in this case, because you're already multiplying by 10, it's very similar. It won't matter. Yeah, and it doesn't matter what the, yeah. So sine of 60, Opal, I'm confused. Are you saying sine of 60 is 0.86, 0.866?
Yes, I think because you were trying to estimate what is sine of 75, and since we already know certain signs, right? We memorize that the 60 is 0.8, and we know the sine of 90 is 1, so we know it has to fall between 0.8 and 1. So you're right. You did
Exactly. Yes. Yes.
So that's how I figure. You know, since I didn't know the sine of 75, but I did know the sine of 90 and the sine of 60. So I've said it had to fall between 0.8 and 1. Is that a rational?
Yeah, that's exactly right, and that's exactly what you were expecting. Nobody's really expecting to know what sine 75 is. They just expect you to know. Like, that's why they gave you the answers so far away in range, or why I gave answers that were so far away in range, because it would be enough for like you to like basically guess, especially they say approximate. How did I choose between sine and cosine? Okay, so we're looking for the upward component. We don't care about the x and y component in these two directions, right? We only care about the up and down right now in this case. The up and down is right here, this line, right? This side of the triangle, right? So we can make our things. We know the angle is 75, and we know we're looking for, we'll call it y. We'll call this, whatever this is, y. We're looking for y over t. Well, what is y over t? Well, this is the opposite angle because the angle's right here. This is opposite. This is hypotenuse. Opposite over hypotenuse. So SOHCAHTOA, SOH is sine. So you do sine 75 rather than cosine 75. If you're looking instead for this side, which is the adjacent or the x component, then you would use cosine 75. But in this case, you're using sine. Does that make it clear? Okay, so and about the T is, oh, the T is tension. I'm sorry. Yeah, it's a little bit confusing, but the T is tension because the bicep is a, like I mentioned, the bicep is basically like a string or a rope. All muscles are, so we use tension. And we divided both sides by 0.2. So because we're trying to isolate tension, that's what we're trying to find. So we want to set, if the arm is not moving, that means F net is 0. That means you want to set the up equal to the down. The down we know is 9.8 times 0.35 because it's torque. So this is the torque of the going down of the weight at this end. And this T times 0.2 is the torque of the bicep, right? And we set them equal to each other if we want to isolate the torque. If we want to isolate the tension, we divide both sides by 0.02, okay? So we do this force times the distance to get the torque, and then we divide that by the distance of this to isolate this force.
Mark,
Yes.
could you rewrite that again, like to
Which part?
to solve that variable for T, because I'm pretty sure a lot of people are still trying to figure out how did you. Yeah, thank you.
No problem. Okay, this is going down. So again, we know this is a torque problem. Torque, this is, I'll write my taus like this, if it makes it easier, okay? Oh, that looks kind of wrong. I'll write my taus like this. This is tau, this is T. Okay, tau is equal to force times distance, okay? We know that the tau of this, the torque of this is equal to the force, which is mg times 0.35, because that's how far away it is from the point of pivot, which is the elbow, right? We know, and we'll call this weight, the tau of the weight. This is the weight. Then we also have the tau of the bicep going up. That's equal to T, which is the tension of the bicep, which is the force exerted by the bicep, times 0.02. We know that because one is going down and one is going up, and the elbow itself, the arm itself, is not moving up or down, it's not rotating. So that means the net torque, just like with the net force before, the net torque is equal to 0. If the net torque is equal to 0, we know that TW and tau W and tau B are equal. Therefore, we can set it like this: mg times 0.35 is equal to T times 0.02, right? We want to find out what T is, so we want to isolate T. We know what M is, we know what G is, we know that 0.35 is on this side. So we would, in order to isolate T, we would just simply divide both sides by 0.02. And then this together is what T, tension, is equal to. Does that make sense? Why did I not subtract from the entire level arm? Because this is not the point of pivot. This is the point of pivot. They told us that this was 0.35 away from the pivot point, and they told us that this was 0.02 away from the pivot. All we care about is this relative to the pivot, not from each other, not from anything else, just from the point of pivot. The point of pivot is the elbow, and that's okay. Yeah. Anything else? Any other questions before I continue?
And the T, you're finding the sign.
Go ahead. Sorry.
You're finding for the T you're finding. But how can you find that if they didn't give you the value for the opposite?
I'm not sure what you mean by the opposite.
So like the sine of 75 opposite over hypotenuse in order to find what T is?
As people are doing fireworks outside, sorry about that.
Did they give you that?
So they gave us what the angle was, 75. Technically, and we're looking for only for the up component, right? The up component is always this side. So we'll call it Y. The up component is Y, and it's this right here, from here to here.
but that would be y over t. But since there's two unknowns, how
Well,
did you?
So we actually we can find that out because we know that sine of 75 is equal to y over t. And then we can actually substitute in two. Do you know the phrase one variable, one equation, one unknown, one equation, you can solve it. Two unknowns, two equations, you can solve it. Three unknowns, three equations, you can solve it. We have two unknowns, two equations. So you're right, we don't know what y is, but we actually do know what t is equal to. T, we just said it right here, t is equal to mg times 0.35 divided by 0.2, right? You just substitute this in here for t. And then you multiply that, and then if you want to just isolate y, you just bring that over to this side. In this case, though, however, we know that sine 75 is almost 1. It's practically equal to 1, right? So we know that y is practically equal to t. What we're actually looking for is not t, we're actually looking for y. But because we know that sine 75 is practically equal to 1, y is practically equal to t, and we know that if we find t, we practically know what y is. Does that make sense?
Yes, but that was a little bit. Yeah, I get it. But that was.
And somebody asked, there is one more topic we'll be covering today. It's centripetal force. So if you guys already have a clear understanding of centripetal force, you can go. But the only topic left is, I believe, centripetal force. Let me just double check actually before I say that and we miss something. Centripetal force, and then and gravitational force. So centripetal and gravitational force are the only things left. Gravitational force in big G mm over r squared, if you guys know what that is. So yeah. I'm sorry that this went so long. It was just because there are a lot of questions and I tried to go in depth with all of them, but yeah. Can we move on from this clicker question, or do you guys want to spend some more time on it?